So we're going to take a look at problem 7. So we've got 38% of Americans drink bottled water more than once a week. We've been hired to investigate bottled water consumption in St. Paul. We're going to do a sample. We're going to assume the population proportion of St. Paulettes, or St. Pauletes, who drink bottled water more than once a week is 0.38, the same as the overall proportion of Americans. And in this case, make a note of the fact that they want you to use the z-tables. So the first question is, what is the expected value of the sample proportion? And since we have no other data to calculate a sample proportion, we'll use the same proportion given for the population, which is 0.38. Calculate the standard deviation of the sample proportion, we'd use a much more involved equation. The standard deviation of the sample proportion is the square root of the population proportion times 1 minus the population proportion over the sample size, and we take the square root of that quantity. We can use our toolkit, however, to get a much more accurate and faster result. So if you go to your statistical toolkit, so if you open up your statistical toolkit, in the normal probability tab, you can see for population proportions of infinite population, or where the population size is not given, which is what we have. We have a sample size of 540. We have a mean population proportion of 0.38 that we were given. And in this case, we have no probability that we're trying to find. We simply want the standard deviation of the sample proportion, which is the sigma sub p bar. So in this case, it is 0.0209. If we round that to 4 decimal places, which we were asked to do. And as we said, because they didn't give us information in order to calculate the expected value for the proportion, we'll use the population proportion that we were given of 0.38. So checking those answers, you can see that both of those are correct.